Hi everyone, this is the second of 3 lessons on factoring. So our first lesson, which was lesson 2.3, talked about factoring and pulling out terms that are in one or more terms in an overall equation. Now we're going to start by looking at if we have these equations, okay, that I call kind of neatly packaged up, okay, two terms multiplied together in brackets. How do we multiply that back out so we can expand it and use all of the terms within the equation? So we do that with a rule known as FOIL. Okay, and what FOIL means is it's in order to multiply each of the terms out so that we end up multiplying it out properly. So what FOIL means is it's actually 4 words: first, outside, inside, and last. So what we do is we start by taking the first terms, so I'll write the F here, in this case the 3a and the 4c, and multiplying it together. So 3a times 4c is 12 times ac. Then we multiply the outside terms together, in other words, the term at the very far left, so 3a, and the very far right, 3d, that's the O in FOIL. So 3a multiplied by 3d, or negative 3d, I should say, is negative 9AD. You can see a second term here. Then we do the inside terms. Okay, so the two terms on the inside of the brackets, in this case, write the I here, the 2b and the 4c. So negative 2b times 4c is negative 8bc. And then last, okay, which is the last term in the first set of brackets and the last term in the second set of brackets. I'll write the L there. So in this case, we end up with negative 2b times negative 3d, which is positive 6bd. Now you don't have to do them in that order. It's just easy to remember that acronym that way. But as long as you do all 4 of these operations, you will have properly multiplied out this equation here, which in this case is 2 binomials. So you have monomials. So that would be like 3x, okay, so one term. You have binomial, which is something like 3x plus 2. So there's 2 terms here. And then in the last lesson, we're going to talk about trinomials, which would have 3 terms. So let's say 3x squared plus 2x plus 4, okay? So you end up with, that's just stating the number of terms in each of those expressions. So each of these expressions, sitting here in brackets, would be considered a binomial. Okay. So I'm going to run you through some of these basic rules. You can use the FOIL rule to multiply kind of all of these kind of duplicates out, but these are just some nice rules that you can either remember to follow or again, use FOIL. The first one is known as distributive law. So if you've got something like A multiplied by a term in brackets, okay, or an expression in brackets with multiple terms, x plus y, you multiply that a in to every expression. So that's the same as ax plus ay. So I've given you an example for each of these. So the example of this is you have 2 multiplied by x plus 4. You multiply the 2 in to each term, just like when we talked about factoring. Remember when we pulled out a number? Okay, so if you multiply the 2 out into both, you get 2x plus 8, because 2 times x is 2x, and 2 times 4 is 8. Okay, remember, if we worked backwards from 2x plus 8, we could factor out the 2 and get to this answer here. Okay, so I'm trying to show you how to work both ways, factoring and then expanding out. The next two are just versions where you have something. In this case, we have x plus y squared and x minus y squared. So those are the same as writing x plus y times x plus y, or x minus y times x minus y. Okay, that's what that squared term is really signaling. So you end up with, if you expanded it out, you would end up with terms like this. Okay, so x squared plus 2 times multiplying these two together plus y squared. Okay, and the only difference with x minus y squared is you have a minus sign here. Now, if you want to use FOIL to do that, you'll get the same answer. Okay, so if you do this, you get the first terms multiplied together. X times x is x squared. The outside terms, okay, which is x and y, so you get plus xy. The inside terms, okay, which is y and x, which again is xy. Doesn't matter in what orientation those terms are in. And then you have the last terms in each expression, which is y times y, so plus y squared. So if you simplify that, you get x squared plus, now you see these two terms, they both have just x and y. So you can add them together, okay? That's called collecting like terms. So xy plus xy would give you 2xy, right? Because you have two of them, plus y squared. Okay, so you end up here, I'm just going to erase some items here to make it a little cleaner. You end up with the same answer as this, okay? These are meant to help you do them faster, okay, once you get used to the rules. The same thing goes for x minus y times x minus y, okay? So using FOIL, we would get the first terms, x times x, which is x squared. Then the outside terms, x times negative y, which is minus xy. The inside terms, which is negative y times x, again, minus xy. And the outside, or the last terms, sorry, which is y, negative y times negative y, which gives you positive y squared. Okay? So collecting the like terms in the middle, that are both xy, we get x squared minus 2xy plus y squared. Okay? So it's totally up to you whether you choose to remember this as a rule or you choose to just use FOIL. Okay? So let's start looking at a few examples. Expand the following equation and simplify. 3 times x plus y minus x plus 2 squared. So I'm going to start by writing this out. Okay, I'm going to show you it using FOIL. Okay, because that's the kind of expanded version as opposed to memorizing this rule. It's totally up to you. The reason I'm doing that is I'm kind of showing it back to basics. So if we write this out, we get 3x plus y minus, and then we have x plus 2 times x plus 2. Okay, that's what x plus 2 squared means. So I'm going to start by multiplying in the 3 into both these expressions. So I'm left with 3x plus 3y. Then I have minus, and I'm going to go in order. So the first terms, x times x is x squared. The outside terms, x plus 2, or x multiplied times 2 is 2x. Then I have the inside terms, 2 times x, so plus 2x. And the outside terms, 2 times 2, which is plus 4. Okay, I kept all of that in brackets because we have a negative sign here. Okay, that negative corresponds to every single term in here. Okay, you have to make sure you distribute that negative in. It's the same as having a negative 1 sitting behind this. Okay, so that's a very common mistake I see in a lot of students when it comes to math. So propagating that negative in, we would get 3x plus 3y minus x squared minus 2x plus 2x is 4x, so minus 4x minus 4. So now you can see we can actually collect some like terms here. We have a 3x and a negative 4x that can be combined because they have the same term. So if we do that, we have 3y minus x squared. Then we have 3x minus 4x, which is just minus x minus 4. Okay? And we can't simplify that any further because none of these have the same terms that are remaining. This one has a y, this one has an x squared, this one has an x, and this one is just a constant. Okay? So let's look at another example. Expand the following equation and simplify. x plus 3 squared plus 3 times y minus 4 squared. Okay, so again, I'm going to start by writing these out. Okay, or simplifying them out. So we get x plus 3 times x plus 3 plus 3 times y minus 4 times y minus 4. Okay, all I'm doing is showing you the version to write it instead of putting the squared sign. Okay, now if I use FOIL, we have the first term, x times x is x squared. The outside terms, x times 3 is plus 3x. The inside terms, 3 times x, which is 3x. And the last terms, 3 times 3, which is 9. Then we have plus 3, and doing the exact same thing again. The first terms, y times y, is y squared. The outside terms, y times negative 4, is negative 4y. The inside terms, which is negative 4 times y, so minus 4y. And the last terms, negative 4 times negative 4 is plus 16. Okay? Now remember, in the last example, we had a negative sign. So remember that propagated all the way through. The same thing happens when you have a number like 3. Remember the first rule that we saw there, which was a to the x plus y is equal to ax plus ay. So we have to now distribute that 3 to each one of these terms. And if we do that, we get x squared, okay, plus, in this case, we have 3x plus 3x, which is 6x, plus 9. Then plus, propagating that 3 in, we get 3 times y squared, minus 3 times negative 4 is negative 12y. 3 times negative 4y is negative 12y. And 3 times positive 16 is 48. So now we have 2 sets of like terms here. We have a constant of 9 and 48, so those can simply be added together. And we have a negative 12y and a negative 12y. Again, they both have just y in them, so we can collect those terms together. So simplifying this, we're left with x squared plus 6x. Then 9 plus 48 is 57, so plus 57. Plus 3y squared, and then we have negative 12y minus 12y, which is minus 24y. Now the way I like to write them in terms of a final answer is all of the kind of higher order exponents, so squareds, first, and then the items with just the x or y, and then the constants. So if I did that, I would just rearrange this as x squared plus 3y squared plus 6x minus 24y. So you can see the squared terms I did first, then the terms with the exponent 1, and now the constant, so plus 57. You don't have to in your final answer to that. It's just the way that you'll typically see my solutions completed. All right? So I showed you a couple factoring rules to start off. Okay, and now these ones are, again, different factoring rules, but they're using what's called, they're using FOIL. Okay, so the first one you might recognize, x plus y times x minus y, is just x squared minus y squared. This is the difference of squares that we talked about. Okay, and these two versions are similar to when I just showed you FOIL for an equation, right? So an example of them is x plus 2 times x plus 4. It equals x squared plus, and in this case, if you want to do it quicker, you can just take these two numbers that you have here, and you add them together, multiplied by x, and then your final solution is those same two numbers multiplied together, okay? That's going to come in, that's going to be a really important piece to kind of memorize and think about when we talk about factoring trinomials in the next lesson, okay? The same thing works if you have one with a positive sign and one with a negative sign. The difference is this term is a minus b instead of a plus b, okay, where a and b are these kind of rightmost terms. And instead of plus the product of them, AB, it's minus the product of them, okay? Okay, so let's look at two examples just to see how this works. Find the product of the following, x plus 2 and x minus 3. I will do it both ways. Okay, first I will use FOIL. And second, I will do it using the rules we saw in the last slide. So if we start with FOIL, we have x plus 2 and x minus 3. Our first terms are x and x, so that's x squared. Our outside terms are x and negative 3, which is minus 3x. Our inside terms are 2 and x, so that becomes 2x, positive, because they're both positive. And our last terms are 2 and negative 3, so that 2 times negative 3 is negative 6. So we can collect these terms in the middle here, and we get x squared, negative 3x plus 2x is negative x, minus 6. So if we do it using the rules, okay, remember, we have x plus a and x minus b. That's the same as x squared, okay, plus, in this case, a minus b x, plus, minus a times b. Okay, the last term being product. So in this case, we have x plus 2 and x minus 3. So that's equal to x squared plus, in this case, 2 minus 3x, minus, in this case, a and b. So 2 times 3. Okay? So if we solve for that, we get x squared minus x minus 6. Okay? So we get the same answer either way you want to do it. Right? Okay, so let's look at our second example. Find the product of the following. 3 times x plus 4 times x plus 5 plus 2x. Okay? So we're going to find the product, and then we're going to simplify all the like terms. Okay, so again, in the previous example, I showed you using both ways. In this case, I'll show you, again, starting from first principles using FOIL. So if we have that, we have 3 times x plus 4 times x plus 5 plus 2x. So I'm going to multiply out these two terms in brackets. So that equals 3 times x, or the first terms, x squared. The outside terms, x and 5, becomes 5x. The inside terms, positive 4 and x, is 4x. And the last terms, 4 and 5, 4 times 5 is 20. And then that's all plus 2x. So now, to simplify this, we have to distribute the 3 to each of these terms. Okay? You can either simplify the 5x plus the 4x first, or you can multiply it out. Okay, I'll just multiply it out. So this gives you 3x squared plus 3 times 5x is 15x, plus 3 times 4x is 12x, and 3 times 20 is 60, and then plus 2x. Okay, so the 3x squared and the 60, those are the only terms that look like that, so we can't simplify those any further. But we have 3 terms here that all just have an x, so they can simply be added together. So we're left with 3x squared, and then we have 15x plus 12x is 27x, plus 2x is 29x. So that's plus 29x and then plus 60. Again, you'll see I always like putting the terms in this order, okay? The terms with the highest exponents first, and then the constant at the end, okay? So that was all I had. Again, like I said, these are going to be short lessons on factoring, 3 short ones. But I do very much encourage you to look at the practice problems, okay? So the practice problems are the most important piece here because all of this is practice, 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 okay? If you have any questions, please feel free to send me an email. Thanks, everybody.